The new Core i7 processors, also referred to as the Central Processing Unit or CPU, have a total of 20 PCI Express lanes with 4 controllers on the pin grid array package. This gives embedded designers the flexibility to use the PCI Express interface for multiple simultaneous applications, including graphics and non-graphics applications. Of the 20 lanes in the CPU PCI Express interface, lanes 0 to 15 are controlled by 3 controllers. The allowable configurations of lanes 0 to 15 are 1 by 16 lanes, 2 by 8 lanes, and 1 by 8 plus 2 by 4 lanes. The 3 controllers can automatically operate on lower lane width modes, allowing as many as 3 simultaneous operating devices on these 16 lanes. The additional 4 lanes, lanes 16 to 19, have a single controller that can be configured to operate in 1 by 4, 1 by 2, or 1 by 1 mode. Note that the controller associated with these 4 lanes cannot be used to function with lanes 0 to 15. Thus, lanes 0 to 15 cannot be combined in any way with lanes 16 to 19. Also, these additional lanes are available only on the pin grid array SKU of the new Core i7 processor, not on the ball grid array SKUs. Thus, on the CPU, a total of 4 PCI Express devices can operate simultaneously in the combinations discussed previously. CPU PCI Express interface supports both Generation 1 and Generation 2 compliant devices, allowing both 2.5 gigatransfers per second and 5.0 gigatransfers per second frequencies. On lane 0 to 15, when a single by 8 device is plugged in, it is mapped to lanes 8 to 15. When 2 by 4 devices are plugged in, they are mapped to lanes 8 to 11 and lanes 12 to 15. Lane 0 on controller 1 corresponds to lane 0 on the PCI Express interface on the CPU. Similarly, lane 0 on controllers 2 and 3 correspond to lane 8 and lane 12 respectively on the PCI Express interface on the CPU. The configuration of the CPU PCI Express bus is statically determined by the BIOS prior to initialization. The BIOS determines the configuration by looking at the presence detect pins on the CPU, called CFG6 and 5. When CFG6 and 5 both have a value of 1, the controller operates in 1 by 16 mode. When the value of CFG6 is 1 and the value of CFG5 is 0, the controller operates in 2 by 8 mode. When CFG6 and 5 both have a value of 0, the controller operates in 1 by 8 plus 2 by 4 mode. No strapping is required to enable the additional 4 lanes, that is, lanes 16 to 19, in any of the permissible modes, as these lanes have a single dedicated controller. The CFG6 and 5 inputs both have a default value of 1 if they are not terminated on the board. Thus, by default, a single by 16 controller is enabled. Hot plug is not supported on the PCI Express interface on the CPU. If a device is not present at power-up, it is not detected when it is plugged in after power-up. Also, the strap values are read on power-up, and the BIOS enables the appropriate controller based on the value read on CFG6 and 5. For example, if on power-up, CFG6 and 5 both have a value of 1, then the 1 by 16 controller is enabled. A single device of width by 16 or lower will be detected on power-up. But if 2 devices of any lower width are plugged in, only one of them will be detected. The PCI Express lanes can be reversed for ease of design and layout. Lane reversal occurs statically, which means that the BIOS needs to configure the reversal before the relevant root port is enabled. For the by 16 configuration, only one reversal option is supported, allowing either a straight or a rotated CPU on the motherboard. No other combination of partial slot reversal is permitted. The reversal on by 8 and by 4 configurations is applied in a similar fashion as shown. The normal or reversed configuration is determined by the CPU configuration pins CFG3 for PCI Express lanes 0 to 15 and CFG4 for lanes 16 to 19. A value of 1 on these inputs would indicate normal operation, and a 0 would indicate reversed mode of operation.